means I'll get -2 greater than or equal to -4. Is that true? Well, yeah, -2 is greater than or equal to -4. So that means I'm underneath the line. I got a true statement. I need to shade underneath the line. So I'm shading underneath this blue line, everything underneath it. Okay. And so if we're being really careful, where did the overlap happen? Turns out it happened like in here, this little triangle. So I'll just highlight that in black. This little triangle is where all three shadings overlapped. This guy here. So this triangle, these markers don't like to mix. Anyway, this triangle right in the middle is our feasibility region. All three colors overlapped in that triangle, so that is our overall solution set for this system of inequalities. Okay, so I'll pause here and ask if anyone has any questions. Okay. So yeah, so the idea is just, if I give you a system, just graph all the inequalities together and look for where they all overlap. And that's our solution. So again, if you're doing this at home on paper, if you have colors, please use colors. If you don't, just at the end of your work, make sure you really make it clear where the feasibility region is. Shade it in extra dark, or like draw an arrow to it and say, this is it. You know, something, somehow indicate it to me really clearly where it is. If we can't tell, and I won't know what to do. I won't be able to grade it properly. So that's sort of, you know, it's just bad. So be careful. Just be sure you're being as neat about this as you can, so that we know what you're doing. But here we go. Here's our system. I want to point out one thing. How are we doing on time? Okay, good. We still have 25 minutes. I want to point out one thing. So notice there's some terminology I want to point out. First, about this example here. Notice the feasibility region made a triangle. It made a nice shape, right? This would be an example of something that I would call a bounded feasibility set region, I suppose. This is a bounded feasibility region. So when I say bounded, I just mean it makes a shape. It makes a nice finite shape that I can identify, right? This is a triangle, so it's bounded. Yeah, because it makes a nice shape. So bounded just means makes a closed shape. I think if you look in the book, they have a more technical definition about it being contained in some big circle or something, which is true, but like, I don't think we need to make it that technical. Let's just say it makes a nice closed shape. In this case, it made a triangle, so this is a bounded feasibility set. We like bounded ones. If we get a bounded feasibility set when we're doing a linear programming problem, it's going to make our lives easier. I will get into that maybe tomorrow, but definitely next week, about why that is. But I just want to point out this terminology now. These are good. Let's see an example where that doesn't happen. Because there will be examples where that does not happen, and we still have to know how to deal with those. So what would be the opposite of bounded? And of course, I'm supposed to say that the opposite is unbounded. What does that look like? Let's see a quick example where we get something unbounded. So here's my system. X is greater than or equal to 0, and 2x plus 1 is less than or equal to y. So here's a simple system with two inequalities. I'm going to graph this. Be slightly faster in my graphing here. I'll still walk through the steps. So the first thing I do, of course, is let's graph the first guy. So I just need to graph both of these together. Let's graph this one in red. X greater than or equal to 0. Well, what's x equals 0? What line is that? That's a vertical line, and it's where x equals 0. So I'm looking for x-intercept equal to 0. Oh, well, that's just the y-axis. So actually, I don't know if you guys can hear that squeak. The y-axis is going to be this line. So the x equals 0 is just the y-axis. So I graph it there in red. And now I'm asking for x greater than or equal to 0. So again, that should mean I'm just going to graph to the right of this line. I'm asking for all the x coordinates that are greater than or equal to 0. That means go to the right. So in red, I'm shading everything to the right of this line. Like so. Okay. Well, what's next? We have to graph this other line now. And so I'm going to do that in purple. And let's go ahead and graph that line. If it's 2x plus 1 equals y. So this is in slope-intercept form. My slope is 2. My y-intercept is 1. So I go to 1 on the y-axis. Slope is 2, so when I go to the right by 1, I have to go up by 2. Something like this, maybe. Okay, that's accurate enough. And then I just have to ask which side of that line am I shading. So we'll test a point. What's a point not on this line? I don't know. How about negative 2, 0? Let's try negative 2, 0. So we'll plug in negative 2, 0 into our inequality. Negative 2, 0, that'll give me negative 4 plus 1 less than or equal to 0. We'll simplify that. Negative 4 plus 1 is negative 3, less than or equal to 0. And this is definitely true. Negative 3 is less than or equal to 0, because it's less than 0. So I go to where that point was. That point was over here, above this purple line. And so I have to shade above the purple line. So that's what we'll do. And then we just ask, where did the overlap happen? And the overlap is happening up here. It's sort of pointy region up here. I'll highlight it in black. This region up here is where the solution happened. But notice, it's not a closed shape. Because remember, these lines go on forever. And so technically, this shaded region extends forever up this way. Just goes off forever. It never closes up and makes a triangle or any other kind of shape. It just goes off forever like this. So this can happen, and it will happen. And this would be an example of what we'd say, of what we'd call an unbounded feasibility set. It's unbounded. An unbounded feasibility set, i.e., it does not make a closed shape. It goes off forever in some direction. In this case, it goes off forever up here. Okay, so in some sense, we don't like these as much. They're going to make things just a little more complicated, but we can still deal with them in most cases. And so we will learn how to do that. I think if you took J111 or something like that, we kind of ignored this case of the unbounded feasibility set. We just didn't deal with those. But in this class, we'll learn how to deal with them. There is a way to do so. So fear not, if we encounter these in our linear programming problems, we can still deal with them. They're just not quite as nice as bounded ones. Okay.